Hey chemistry crew, this is Miss Schibbelhut and you are watching Is This a Chemical or Physical Change? Today we're going to be making banana bread and you'll see kind of a couple other side chemical and physical changes along the way. So the goal of this is you're going to have a chance to answer questions along the way if it's a chemical or physical change. And my hope is that you'll see how chemical and physical changes, how this is all around you. And so that now when you leave the classroom today, you can go out and you're going to be seeing changes happening, be able to know if they're chemical or physical changes. So step one, is this ripening banana a chemical and physical change? And always think, how would you support your answer? Is mashing this banana, is that a chemical or a physical change? Answer to number one is the ripening banana chemical or physical change it's a chemical change. You maybe know from your experience that as a banana ripens, you can even taste that it's sweeter. That's a chemical change happening. It's changing starches into sugars through the work of bacteria. So cool. And that's why we use ripened bananas for banana bread, because they're sweeter and mushier. Mushing up the banana then, that is a physical change. It's not changing the composition of the banana, it's just changing the form it's in. Next up is melting butter. Is that a chemical or physical change? The answer is physical change. The butter was changing from a solid to a liquid. It was not changing from butter to something else. So although the molecules in the butter were speeding up so they can move past each other more quickly instead of being locked in its configuration as a solid, it was a physical change. So I put baking soda. Its chemical formula is sodium bicarbonate, H2NaCO3, something like that. And we have salt in there, we have cinnamon, nutmeg, you have flour, chocolate chips, of course, otherwise it's lame. And I didn't have any eggs, so I used Greek yogurt instead. So let's see how that works. So now also there's some sugar in there. Brown sugar because I didn't have white sugar. So now is that process of this batter becoming a loaf of banana bread, is that a chemical or physical change? All right, there it is in the oven. I also don't have a bread pan, so we're using that. So is that gonna be a chemical or physical change, the baking? We'll see. All right, now here I have a bowl of milk and I'm adding some vinegar into it. Should be enough. Check back in a couple minutes. Tell me, is that gonna be a chemical or a physical change? What do you think? All right, you can see here something cool happening. The milk's separating away and it's leaving behind this kind of other substance. A bit like that. So it's becoming curdled. If you know anything about cheese making or anything like that, it's a similar process going on. So this would be a chemical change. There's more complex things going on here, but yeah, we'll leave it at that. It's a chemical change. Next up, we've got some Aldi ads here. Is ripping this paper. This is tiny little shreds. Cutting it with one hand, crumpling it up. Is that a chemical or physical change? It's a physical change, you're right. So now there it is lighting a match a chemical or physical change? That's the first one. And then is lighting this same newspaper on fire. Let's see. Is that burning that paper, is that a physical or chemical change? And why? Burning that paper was a chemical change, as was lighting that match. You could see we have a color change there. It's not red anymore on the tip. It's white there and then black. We have a color change here as well. Paper, seems to have disappeared, but it turned into a different form chemically and now is in the air and making this place smell like I lit a fire. All right, next up over here, I have a hatchet, and I'm gonna take a cow magnet. So these are, you maybe know this already, they're put into a cow's stomach. when they're younger, and then they collect any kind of metal pieces that they might eat because it gets into their feet or something, and then it protects it from puncturing their stomach further down in their digestive tract. So, cow magnets, really cool. I'm gonna magnetize this hatchet right here. Hatchet is steel. So question, is magnetizing this metal, is that a chemical or a physical change? So magnetizing this hatchet here, oh, let's see if it worked. There we go. Magnetizing the hatchet there is a physical change. The hatchet doesn't stop being steel and become something else. Oh, it's not very magnetized. But what does happen is the makeup of the steel and the iron atoms in it become aligned in a different way. So they're not changing their chemical properties, but they are changing something about the way they're set up. And that's on a molecular level. Next up, I have some aluminum foil. The question is the process of changing aluminum ball like this into this a chemical or physical change? To clarify just a bit, what we're changing here is its density. So in deciding if it's a chemical or physical change, you also have to think, is density a chemical or a physical property? Let me show you what we've got. So, like hypothesis, is this going to sink or float? Ooh, that one floats. And what about this one? Sinks to the bottom there. Density is a physical property, and making that ball and like hammering it into that little aluminum piece, that is a physical change. Next up, I have some nail polish here. Is painting my fingernail, is that going to be a chemical or a physical change? So, there's my painted nail. We'll call this a physical change. Even though I'm changing the color of something, it's not changing the makeup of my nail or the makeup of the nail polish. The nail polish is staying nail polish, my nail is staying my nail. So it's a physical change, even though it's a color change. We're thinking about what's going on here. We're not, just blindly following the rules. So what you also maybe know, though, if you've painted your nails before, is that you need acetone to get this off, that it doesn't just come off easily. And so there may be some chemical changes going on here between the nail polish and like the top layer of the nail. That'd be interesting to look into, but it's not always quite as simple as this is a chemical change or this is a physical change. But we'll call this a physical change. Next up, I've got some copper in different forms. This is the bottom of frying pan I've got, and I have some pennies over here. They're looking a little dingy. Over here, I've got some nice shiny pennies, and then right here in the middle, see that penny with some blue stuff on it? Right now, if you're watching this in the classroom, you can look on my desk next to the plants. There's a big rock. Look at that rock and look at some of the different colors on it that may remind you of this penny right here. Is that penny, or all these pennies, turning from this shiny color to this color over here? Is that a physical or a chemical change? It is most definitely a chemical change. We're not painting that tarnished look onto the pennies. That's happening because of oxidation, oxygen in the air reacting with the copper in the penny, making that blue stuff on there. I wonder what that is. We'll learn more about that later. So over here then, I'm trying to reverse the process, and I'm not sure if I was gonna be successful in that or not. I've got kind of a shinier penny over here, and then I've got over here this kind of average tarnished penny, and this penny in here started out like this penny right here. I tried to pick two that were similar. If you look closely here, if I don't get too much glare, one thing you'll maybe notice is, there's maybe a good one, there are some bubbles coming up off of the penny. So when we see bubbles, we know that there's a gas being produced. Right off the penny there. Oh, let's see if we can focus. So I'm gonna take that penny out and see if it looks any different than it did before. And question for you, is this a chemical or physical change? Ooh, I'm actually happy with how this turned out. So you can maybe guess which one was in the vinegar. Hopefully you can see the difference there. The one on the right. And so they started out the same, you'll have to trust me on that, but that is a chemical change then. I turned the penny from this one to this one. Also, here's my plug for the Wausau Farmers Market. I really love the Farmers Market and I love buying flowers. So those are my pretty dahlias. So the banana bread is getting cooked. It's almost there. Is this a chemical or physical change? This is a chemical change. There's several different chemical changes going on there. One is involved with the baking soda. And the baking soda interacting with it to make it rise. So I was looking if I had an oven light. I don't. And the other... All right, sorry about that. We'll have you look at it just a little bit longer. Another chemical change then is going on as the top of it gets, it's like caramelized brown color and forms that crust. A lot of chemical reactions going on there, creating new products from the reactants involved. And hopefully it turns out okay. I'd bring it to you in class, but I may have germs. We'll see. I'll bring it to class if I don't have germs. So that's the end of our video on chemical and physical changes at Ms. Schibbelhut's house. And thanks for answering those questions along the way. And I'll be talking to you in class then. Bye.